All right, we're live. A couple minutes late. Sorry, we're just getting everybody together. Hey, team, how you doing? Good to see you. I hope you had a good weekend and enjoyed Mother's Day with whatever mother is closest to you, your wife or your own. But I'm Chris Neidl, and happy to welcome the team and folks who will be streaming in, I'm sure, to our weekly Monday Epiphyte stream, which is where this team of folks here, many of them are here, and a couple more joining in the next couple of minutes, talk through some of the vision and plans and work related to our open source direct air capture project, Epiphyte. I got one more person here. There's Seth. Great. Hey, Seth, how are you? I know Seth will be on in a second as well. So good to catch up. We covered a lot last week, and I was trying to look at my notes, and I might rely on you guys to clean those up so that we can translate that into actual purchases and decisions. But before we get going, just a couple of little updates. I did get in touch with Peter Saris at UPenn. David and Sandelia were copied on that. And he had a very enthusiastic response and very sort of specific about some potential next steps, including an event that's happening there in September, which could be an interesting date for us to keep in mind for being able to display it to kind of an influential audience. And then the other part was he did mention that he would be up to joining Sandelia and maybe David, time dependent, in the lab soon this week.
Be gone.
What's that?
I'm going to be gone.
Yeah, I know. So hopefully we can. When are you taking off, David?
Thursday, but between now and then, my days are pretty full up.
Yeah. All right. Well, let's see. I did hear from Sandelia. He'll be on. And sorry you weren't able to connect with him. He was in the midst of his finals last week, so that might have explained why connection wasn't made. But he'll be on in just a moment, and we'll do the best we can to see what we can relay to him virtually. I don't know what your thoughts are on that, David, in terms of things that are essential to have you there, or if we might be able to get him in good enough shape with Peter's help to make those changes. But hard for me to say, but I know you could.
Depends on how much reverse engineering he's willing to do. I understand he's leaving in a couple of weeks anyway. So here he is.
Yep, he's here.
Hey guys.
Hey, congrats on finishing your exams.
Yeah,
pretty intense.
Officially done with exams.
Great. So we were just picking up right from where we went. I mentioned a little bit about the correspondence I had with Peter at UPenn. Obviously he's got a lot of great thoughts on the future of this, as well as in the near term, some events that are coming up that are interesting focal points for us. And it does sound he wants to get to the lab to kind of meet up with you there. David was just mentioning he's headed out of town at the end of this week and is kind of doing prep for that. So the window is, probably closed on being able to meet with him at UPenn. Was that fair to say, David?
That's fair to say, yes.
Okay, gotcha. So we'll have to figure out what we can do with virtual guidance here. But let's start with you, Sandelia. I guess since last we spoke, you obviously jumped right into finals. So don't expect major developments on that side. But in terms of what we talked about and how you sort of absorbed that into your brain, just wanted to know where you think you need particular sort of help that we can try to fill in again through virtual means, and maybe with some of Peter's help.
Yeah. So I was able to figure out the whole system based on the GitHub readings that were there. But I might want to make sure that the sensors are right in place before I sort of do any other experimentation or any other replacement. So I just want a circuit diagram so that at least while taking things out, I'm making sure that they're all in the place.
I'm going to try to make a circuit diagram when I can. Do you mean for all the electronic parts?
Yeah. Just the electronic parts, yeah.
Okay, let me see what I can do before Wednesday.
Okay.
Thank you, David. Appreciate it. I know your time is tight. The other thing too that seems to be kind of a immediate change we'll have to do when we were talking about all the stuff in the actual sorbent box itself is that a different mesh that won't cause the material to fall out. And I don't know if we thought that some of the rewiring ideas that we had about sort of separating the wires and burying the sorbent in it so it's perfectly surrounded. That might be just a matter of sort of tweaking, or maybe that is a little more complicated than I'm giving it credit. That we'll just go with the way it's currently configured. I don't know, David or Seth, or any of you had any thoughts on that. What's realistic to change easily, and what might just be part of build 2?
Well, what is our timeline here? Sandelia, when do you need to leave?
I'll be leaving Philly on May of 30th.
Okay.
Like 18 days left.
I'd say that the arrangements we talked about on the wires, which is to make sure they're not actually touching the mesh and that they're buried, probably shouldn't be too difficult, right? And and I don't know, Sandy, whether you've actually swapped out the old sorbent yet, but you've got to take it all apart anyway.
Yeah.
So I think it's probably not a bad time to have a go. If we wanted to buy some new mesh, I think all we need to know is just what the size of the sorbent is, so we can just size something. I can have a look at that out, if it's on the data sheet, or otherwise we just need to just open the jar and make a quick measurement and see what the grain size is. And then we pick something.
Yeah.
I think the only other thing we talked about was whether we want to put some kind of, and I know Ben mentioned that he'd specifically put something on, whether it was little pieces of graphite on the heater wire, just to have a thermal buffer between the wire and the sorbent, so that we didn't run the risk of burning it, heating it up too quickly.
Yeah.
And again, we could probably find something suitable really quickly.
David, I can't remember, you had a response to that last time where you thought that the wire was sort of over, like the thermal protection for it was for very, very high temperatures. I can't remember. I'm just recalling from memory.
I put in some thermal protection, which I never really hooked up. There's some wires sticking out that I think are not actually used, and it's for a higher temperature than this material would want. So I recommend not even considering those. But as long as I would recommend it's in the temperature is in a PID control loop, and I would recommend just starting it out, dialing in a low temperature, and you kind of have to understand how the software works to know how to run it, and just see how fast the temperature rises. I think the PID parameters that are in the latest version of the software are pretty conservative, and they'll prevent it from overshooting too badly.
How far away is the sensor that's controlling the loop from the actual heater wires? Is it actually attached to them, or?
It's actually attached to the wire.
Okay.
So, there's a sensor attached in a couple of different places to each wire, but only one of them for each wire is the one that provides the controlling feedback. And then the sensors elsewhere are just there for monitoring the situation. Like there were a couple buried in the middle of the sorbent, not contacting the heater wires.
Yeah.
And there's one touching the frame, so you could see how much the frame was heating up due to parasitically drawing heat away.
Right. So yeah, there's no. You're right. So there's no chance that if you put some conservative control numbers in, and because of the sensors on the wire, then we know that it won't be heating up. Too
And then
hot.
just watch it. Be ready to shut the thing off if for some reason it gets out of control.
How do you know that, David, if it's out of control?
Well, there you can monitor the temperature. The program has a serial monitor where you can output all the moment by moment temperatures, and you just watch it.
Okay. In terms of changes that need to be made to the software at all, or is it that David is last week? It sounded like that was relatively easy to plug in different parameters for that, or
Well, basically, you have to edit the source code and then recompile it. So you need to know how the Arduino IDE works.
okay. Seth, what's your expertise on that? Just curious, or Zendelia for that matter.
I mean, I can figure it out, but I don't have a lot of experience doing direct Arduino coding. So I'd have to learn the IDE, but I don't think that'd be terribly difficult.
Tim, did you say you could do it?
Yeah,
better
I've been
answering
doing a lot. I can get on the call with Sandelia and help walk him through it. It's not too difficult at all.
Okay.
Okay.
Great. David, is the code in the GitHub or Ling? It is. Okay.
Yeah, yes, it is.
Okay, great. All right. So yeah,
If
Tim.
it's not there, let me know. But I'm 99% certain I uploaded
Yeah,
it.
I see it. Software. I see it right here. I'll just drop it in the chat anyway. Okay, great. So yeah, Tim, that'd be awesome if you and Sandelia could connect on that if you need any guidance. Okay. Going back to your first question though, Sandelia, you had mentioned just about. Did you also have a question about the sensor placement, or was it just all about the wiring it properly?
Yeah, the wiring. So I guess we'll also have to replace the 3D printed sensor holdings, right? So for that, I need what is the wiring system that is being attached to the sensor. So
Okay. All right. So we'll whatever you can offer, David, between now, understanding that you're out of here and your time is very limited, but I think if one thing what we could do is try to get. Are you back, David, before the 30th, or are you gone for the summer?
I'm gone until sometime the first or second week of June.
Okay. All right.
I won't be completely unavailable. I'll be at my brother's house in Florida, but I expect we'll be kind of busy.
Yep. Okay. Well, let's keep in touch over the next couple of days, I guess, and make sure that you have enough to move on that. I guess if not, then we'll try to put our heads together and figure it out without you. Maybe probably some smart people on the call here. So Jay, I know, has a lot of experience in that. So okay. So as far as you're concerned, Sandelia, do you feel that based on your reading, what we described last week, that you're good to go in terms of replacing the sorbent?
Yeah.
Attaching the sensors, we'll figure out the wiring part.
Yeah.
But you have pretty much good availability over the next couple of weeks, it sounds like.
Yeah. The next 2 weeks is going to be very free, so I can give some time.
Okay, great. It'd be good. And Jay lives in Philadelphia too. Oh no, you're in Jersey. That's right.
I'm in Jersey. Yeah.
Jersey, yeah. Okay. Well, I think it would be good too, as Peter asked. I mean, he knows his way around this kind of stuff too. It'd be interesting for him to. I don't know what time he has to kind of gets his hands dirty, but certainly would be interesting to have him in the lab with you to see what the fixes you're making. So let's see what he says in the email I just sent him this morning. All right, great. So I have new mesh. So I don't know if the data sheet has that. I can pull it up right now and we can see.
I just had a look. They're approximately 0.5 millimeter in size, diameter.
Okay. All right, so we can find the corresponding mesh for that. That's pretty easy to put the mesh in and on, right, guys? David?
I didn't do it. I just watched as somebody else did it. Our colleague that can't be named.
Yeah.
It
Okay.
probably takes some physical coordination, if I had to guess.
Let me just see
Yeah.
if there's any good pictures of it.
Oh, wow.
How it
Oh,
takes on.
It's pellets now, the sorbet?
These are pellets. Now we have grains now, or
Oh, that's great.
Kind of like guinea pig food, but a little smaller.
Yeah.
Oh, yeah. Oh, that's great.
but the new one is more like sand. So we don't
Oh.
want it to fall through, nor do we want it to overheat, because if it gets damaged, then it's pretty much toast for all time. So we'll have to see what we can do. Sandelia, are you good with that part? And we'll Venmo you. It's probably just at a hardware store, or we could order it, for you, whatever's easiest. Okay.
Okay. Yeah.
All
If
right.
you feel like the mesh is too flimsy, like a fine mesh is too flimsy, you can buy two meshes, like one that's that will cover the size of the sorbent, and then another one that is like coarser, for structural integrity to put on the outside. Because the sorbent will make it bulge out.
Yep.
Okay. And the other main thing I think that we wanted to at least try to do in the very, very short term was just with the ceiling. So Tim, I can't remember if you sent me a particular product for that you recommended.
Sorry, for what?
For the ceiling, the air ceiling, we're gonna try to put I think a silicone coating over it and then clamps.
Yeah, I can dig up the link again.
Yeah, do you want to just Discord it to me or whatever, and I'll if it's the kind of thing that probably has to be ordered online, then I'll just order it to you, Sandelia. Would it be helpful, Sandelia, if we did this, like you actually putting this stuff in and made next Monday's call an actual working call, so you had other eyeballs on it, or would you rather do that and show the work on Monday, or what's your preference?
Yeah, I can live stream it next week. If that's yeah.
Would that be better? I know David won't be here, but if Seth and Tim and Jochen and Ling are here, it would be good to just do those in order. Ling, there was the updated designs for the new sensors for 3D printing.
I never finished them because I went on vacation, like that was a long time ago, and I didn't want to end up with a design without having the sensors in hand, because likely we'll have connectors and stuff that we're not accounting for. You might spend a lot of time 3D printing it just to find out, like, oh, the size is correct now, but we're missing something. So I had sent Sandelia a message on Saturday saying that like I'm on standby if you do need to make a sensor mount. My suggestion at first was like jury rig it, maybe use a cardboard box. I don't know, like I think anyone can make a cardboard box, but if you feel like we have a good idea on like all the connectors and where it should go in the duct, and now that you have the sensor in hand, you can make physical measurements. Like if I ask you, can you take tons of pictures of it and then also give me the like envelope measurement, whatever, you can give it to me, then I feel more like designing a box is not going to be a waste of time. And I could probably print it in my lab also. I just have to do it like not during many hours because I have deadlines here.
Yeah. Sandelia, I think you have a 3D printer there too. If I'm not sure if that's easier for you even, but that might be an option if you just have the designs laying and print them locally.
Okay.
All right.
The design is the hard part. Printing is easy.
Yeah.
Well, if printing is easy, if you've done it before.
relatively, yeah.
Okay, great. Any other questions, Cindelia? In terms of reading the GitHub, I can't remember if the actual operation of the systems, not that I would understand it looking at it, but like in terms of just guidance is once we make these changes, how to run the machine. Are you good to go on that part, or do you need David's input?
Yeah, I'm good to go with some parts, but if we just give a quick rundown, it will be good. Yeah.
Cool. David, are you able to kind of talk us through that a bit right now, or is that something?
Well, I'm not sure how to use GitHub myself. There's really just one file on there, I think. The important thing you need to do, though, is first load the. I'll send you some links with the instructions. You need to load the Arduino IDE onto your computer, and then there's some libraries to install and so on. And then as far as getting the file from GitHub, I think you just go to that link and download that one. There's a file that ends in .ino.
Yeah.
That has the whole program.
Okay.
Yeah, I'm looking at it right now.
David, can you say what parameters are used for the PID? What variables control the PID parameters in the program?
You mean the PID parameters?
Yeah.
Let's see. There, do you have it open?
I do.
Okay, I have to open my copy.
All right. While we do that, unless it's on hand right now, yeah. If there's other questions, first of all, Sandelia, it sounds like you're in relatively good shape. Oh, go ahead, David.
Jay, on line 152, there's a structure, PID parm.
Yeah, I see it.
Okay, so you kind of have to understand how I set up all the different sensors. But the first line shows that the temperature sensor number 5 is PWM channel 1, and the parameters are, let's see. Oh, the structure is actually declared a little above that at line 144, so that shows what all the
Oh,
those
okay.
parameters
Oh,
are.
yeah. So the last three are KP, KI, KD. Okay, that's what is
Yes.
that? Those are the gains, right?
Yes, that's right.
Where's the integration?
Well, KI
Oh,
is the interval
oh,
constant.
I see it. Oh, yeah, I see it now. Okay.
What is that for, David? Just to give some context, what's the what is this particular part of the code for?
Well, there's a feedback loop that controls the temperature, and those are just some parameters that tell it how to operate.
Yeah, it's called a PID. So KP, KI, KD, they're the constants that determine what the proportional integral and derivative are. It's like a concept that everyone knows, but like it's hard to get right. But
Yeah, yeah.
we'll just have to mess with it.
Okay.
So so this will determine the control loop response, and what is this like what is the overall loop response? What did you have in intend? Like bandwidth and is it flat, or is there some peaking or?
Oh, there's a little bit of peaking. I basically did a lot of trial and error to get it to respond the way I liked.
Yeah, because there's a lot of parameters probably with the sorbent and the way it's held that'll I guess
Yeah,
adds a delay or whatever.
yeah, without the sorbent or with a different sorbent, or without the wire touching the frame, those are all things that'll make it different.
Oh, okay.
Yeah, I think the main problem is that the sorbent chamber is kind of thick. It's like 1.5 inches, and then the heating wires are probably in the middle. So when you're heating, you want to make sure that the edge of the sorbent is also getting heat. So so the feedback loop is slow. It's like 1 minute, on the order of minutes.
So what's your criteria for it works right?
I look at the data as it heats up. I
Uh,
put it with Excel, and I just look at the response to see if it, how long it takes to heat up and whether it overshoots and whether there's ringing.
and you minimize that ringing or the overshoot or both?
Yeah, I try to minimize both.
Okay. All right.
It was kind of a long process.
Yeah, it probably takes a while. So what's the sensitivity? Which parameters are the most sensitive, or they all matter?
They all matter. The derivative parameter is probably the least important.
Okay.
And they interact. So you change one, you have to change the other sometimes.
Yeah. Okay. All right.
Okay.
All right. All right. Thank you.
Great. And Tim, David, the part of the code here again, Tim, if this is already completely clear to you, I didn't know if the lines that we need to change, if that's worth relaying to Tim and Sandelia, unless Tim, if you're good to go on this, then we don't need to cover that.
Yeah, I think I can work it out with Sandelia, no problem.
Okay, cool. Great.
Yeah, this is pretty readable code. If needed, I can also come up with some ideas.
Okay, great.
I remember reading it. I haven't read it in a while.
All right. So between now and next Monday, then we need to get new mesh, some of the sealing material, and for clamps, do you think just sort of there's a kind of a standard? I don't know if we have any recommendations based on the surface that we're trying to close there, but that's probably just anything that we can make tight. Probably stuff in the lab, but if there's a piece of equipment there, I'd like to order it to Sendelia's house today. And then we need to, I guess, use a cardboard kind of jerry rig for the sensor holder for right now. And then when we look at it next week, maybe we can get some pictures or measurements, and then Ling, we can add the attachment to it after the cardboard box, but we'll use that tomorrow or next week for testing.
You're talking about the CO2 sensor?
Yeah.
Do we have new ones?
Yes.
Okay.
So they're a different shape.
What did you get?
Oh yeah.
Let me see it here.
Yeah.
Sensors. Where is it here? Cindy, I don't know if you have the name of it on you. I haven't.
Yep.
Sensirion. Yeah, so it was the one we did. Is the number is
Yeah. It's
it's
the SCD40.
yeah.
Sensirion SCD40.
Is that the one we got?
Yeah,
Let's
but
see.
we got it as part of the SCD41 eval kit.
Okay.
Or it came on the board.
Jay,
It's 31. It's 31. You're right. Here,
31.
I'll put it in the chat. It's the STC 31.
okay.
My mistake.
So the software will have to be changed to read that one.
Yeah. It's quite different. And that's why I was holding off on redoing the box, is because it's quite complicated actually.
It's the bigger sensor, right?
Yeah.
It's bigger in terms of like the eval board being a bit. No, wait. It's not bigger.
No, it's not bigger. And
It's on the flexible circuit board thing.
Oh, okay. Then I'm thinking of. I thought it was the longer, more rectangular one instead of the
I
sensor
put a link to it in the
itself.
chat.
Oh, I see. Oh, you did. Okay, I'll look at it.
Yeah, I think the fact that it's smaller and it's on a flexible
Oh,
thing,
wow.
it makes it a little bit requiring creativity to make a mount. Yeah, I just like can't do it in a rush because I had like a day left, and now it's like we don't even have the sensor in hand. I can't get feedback on this. We all need to do design reviews. So I have a question on like what the status of the current Epiphyte device is. Has it been run ever since Sandelia joined? He just
Sure, I'll be back on in a second.
passed.
I think he was having an issue. I don't think it has been run, right, David? Since December.
Right.
Yeah.
I haven't even been in there since, I guess, December.
Yeah.
Probably
Well,
because-
Sandelia was in the lab last week. I don't know if you saw that stream. And we just went over all the different parts of it, sort of zoomed up and talked through some of the things that we need to change or work on while he's in town. So I'll send you the link to that if you didn't see it, and you can take a look.
Okay. Well, I was just thinking that it might be good to run it before you start swapping out parts, because when David was running it at first, there were some interference issues, like if the wires are not, like if the wires are touching, crossing some weird way, then you're gonna have like data graph that drop out and then come back in, and like you don't want to be swapping out parts and then just to find out like it's not working, and I don't know if it was working in the first place.
Yeah, the problem was when the wires carrying the signal to the sensor were routed too close to the wires going to the heater wires.
Yeah, so you'll have to like, sometimes the wires have to be just separated. If you see wires touching that are not doing similar things, they probably just need to be separated. If you can twist the wires together, if they can go in the bundle. I heard that if you just like twist them, wind them around each other like a braid, then that also can reduce the interference. But yeah, like, I mean, that may not be the only problem. Like, the problem may come from a lot of different sources. If you find out that like you just put it together and it's not working.
Did you turn anything on last time, Sandelia? Just
No.
it all? Okay.
Yeah.
All right. Okay. Well, I think what we could do is, I don't know if you'll be in the lab at any time between now and Monday. Hopefully you'll meet up with Peter, but
Yeah.
I wonder if there's a way to run it before. If not, we can do that first thing of next Monday's call, but it's based on your availability and comfort, Sandelia.
Yeah, I'll try this weekend and we can go and run the code and see how it works.
Okay, great. Okay, so for next Monday, then I guess in order, if we get you the mesh, immediately, I don't know if you want to do that prior to the call over the weekend. And then we could do Monday could be, I guess, first replacing the sorbent and then putting the new sensors in and see if we can get that as far as possible next Monday, and then have the benefit of these people on the call giving thoughts if that's okay.
Yeah. Okay.
Great. And then maybe we'll also, Tim, we'll just talk through the clamping live as well. For the material that you were talking about, is that just a matter of just sort of slapping it on there? Like I'm trying to think of the time intensity of careful of an exercise.
I think we should just remind ourselves exactly how the thing assembles, because I think that looking at it, the kind of cone shape where it connects up to the box actually slides in, if I was looking at that correctly. So it might be a little bit more tricky. So I'm just, okay, actually, no, maybe not. So on the top, it looks, are there just, how's that whole box assembled? Is it, yeah, it looks like it's just two pieces of sheet that are pressed together.
Oh, it's like, it came like that.
Yeah.
I guess you can open the door.
But can you see, I think you can see there, it looks like the, that, you know, that cone shaped piece fits in, there's like a bend, and it, it might be a little bit more complicated to get that fitted properly. But we can. Okay, do we have like a mechanical model of this, or I can just look up the part from?
Yeah, there is. Let me see. So like I have a CAD of the overall shape of the cone, the duct piece, but there's no like exact replica of the actual thing because I'm not sure if it came with it. I just made it my own.
Oh, sorry then. But that rectangular piece on the bottom left, right? That's the cover plate that goes over the end. Yeah.
Yeah.
Yeah, okay. I don't have one that corresponds to how this clamps together. I only have one that corresponds to the overall shape of this. So I don't know if that's useful to you.
Sorry, say that again.
I don't have a CAD that like so the manufacturer doesn't come with a CAD, I believe. I created a CAD on my own that corresponds to the shape, the cone duct piece, like the whole thing. So I'm not sure if that's useful to you.
Yeah, it could be actually, if you don't mind sending it. But I think maybe also just what we've got here, and then Jochen's got some just made a helpful suggestion. We might want to see if we can make some. There are some simple modifications which might make it a bit easier to get it sealed.
Okay.
Can you hear me now?
Yep, we can.
Oh, Jesus. StreamYard and my microphone. Yeah, what I wanted to say is the material that Tim kindly suggested is I also think is the right one, but the problem is you need two surfaces to put it in between, and I've been studying on the Canva photos and the small videos you've posted there. That would be an issue around the whole square box, I think, because there are no surfaces. It's just the metal sheet.
That's possible.
So what I was asking in the comments before I had a voice is whether we cannot lose the metal sheets on the sides and at the top or the bottom of this to make the whole thing smaller and bolt it directly onto the profiles. That way we might get it sealed.
So if we just look at it with a little bit of distance, Wait 1 second.
Because I didn't, until last week, I didn't know that the box was actually, there was space for the sorbent panel to move in there. I thought it was bolted flatly onto it. I don't know, David, is there a reason why there is this gap in between? Yeah, that.
Wait, this one here, right?
Yeah. Could we lose that? Or are there reasons why it's there?
It's just the way that it was designed. The box is meant for a filter that's 4 inches thick, and so there's the opening there. But we didn't need a frame for the sorbent that was that thick. It's actually thicker than it needs to be, but we assumed that there would be a panel on the end there that would seal up the airflow.
All right.
Not quite that good in practice.
Yeah, it would involve a bit of metal work, but I think if we could put both of the cone-shaped thingies and the metal sheet that they are mounted to directly onto the profile frame, that might give us a better chance for airtightness. I don't know what you think, Tim.
Yeah, I mean, I think there's probably an air conduction path like right around the sorbent material, around the edges of the sorbent panel at the moment. So I think we need some way of sealing that up. And I think what you're suggesting could be a better solution for getting a quicker solution. Yeah.
You mean just making it narrower so there's not as much of a gap? Is that what you're talking about?
Yeah, well, bolt the front and the back side directly onto these aluminium profiles. So you're losing 2 of the 3 or 4 inches or whatever it was. And that way you've got this flat surface that the Viton, this sealing material, needs.
Well, I think for multiple reasons. For the next, we obviously want to get this to as working shape as possible, as we've said, and hopefully it will at least verify for us that the sensors and the sorbent are better. But we've definitely well opened the possibility of a different housing structure in general using a different part. So the next thing that we select for, we can make sure that I don't know why my sound is doing that, sorry. We'll make something that doesn't have that gap or select for something. But I don't think for this immediate next step, for next Monday, we probably won't be able to make any adjustments to that. And for the material there, Tim and Jochen, is it just for very quick and dirty for next week? I'm just wondering if there's something we can put just externally, like even if it's tape or something that literally is plugging holes that we found, just to make it a little bit better with the clamps. Just on the outside.
If you, Chris, if you look at the Canva and on this to make sorbent chamber airtight, right? That little video there you posted.
Yeah.
If you go to second 33.
All right, let me open it up 1 second. All right, so. All right.
Number 2, I think it is, further up.
Yeah.
That one. And not that video, go to second 33 and hold it there.
Right here?
Can't see it yet.
You can't see it?
No.
Okay. Yeah. Oh, I know why. Okay. Wait a second. Stop share. Reshare. All right. So right here. You can see it now?
Exactly. The Viton will work where you've got the yellow circle. It will not work on the surfaces on the top.
Okay. Can you explain the VTOL to me just real quick? Is that
It's just a flat rubber mat, as far as I remember, and you can use it if you have a couple of joining surfaces and you put it in between, and if you kind of bolt it mechanically or so. But otherwise, up there, you will just get it sucked in. You know, you will probably need something like what I suggested from eBay, these little rubber profiles. They might work, but it's definitely normally. That's why I shared this vacuum accessories catalog a couple of weeks ago. There you can see how the VTON, which is normally comes in O-rings or in round flat seals, how that needs to be pressed together and kept in shape in order to keep the airtightness. So it's not that trivial with the box. That's why I'm asking if we can lose the box and just bolt front and back to the aluminium profile, as you can see it there, and put the VTON in between. That might do the trick, but that will require some metal work because you need to lose all four sides of the square box.
Yeah. Is that gap in the circle all the way through, or is that just the two pieces pulling away? I can't tell.
Oh, sorry, it's muted. It goes all the way across.
Can you solder it so it's airtight?
I don't think you can solder aluminum.
With a torch?
Somebody can.
Yeah, that might be a bit advanced at the moment.
Yeah, soldering is possible, but it's a lot of distance that needs soldering. So I'm not sure how homogeneous you get that done.
I think some kind of sealant might be better. Some glue, hot glue, or instant gasket.
so? Would you just basically put that material on? I mean, that'll make it difficult, obviously, for reopening, maybe. But
Yeah.
for the purposes of just getting it tight enough to run some tests, because once we seal that, we don't anticipate, for this build at least, taking the sorbent out anytime soon. And I would imagine it could be with a knife, you could cut that stuff off. But is that maybe the best way for us to go between now and next Monday, is to think of some kind of thing to almost caulk it, whatever the equivalent is for this for metals? Would that be the quickest and dirtiest way that we probably get some improvement for? Obviously not a permanent solution, but
I'm not sure. Tim, what do you think?
I mean, I think you could probably put like a silicone gasket down there, just a strip that might do the job. You'd need to be able to bolt it up tightly. That's probably the first thing I try, because it's probably the quickest thing to do and the least messy.
yeah, it would definitely be less messy. Sandelia, does that make sense to you at all, or? Oh, I think you're on mute.
I'm sorry. So yeah, we were supposed to close that end, right? And I could also see some other end to the bottom. I'll think of a way if we have anything around the lab to sort of close it up.
Okay. Well, if there's anything I can order as well,
Yeah.
Let me know, and we'll at least have something else on hand for you to play with.
Okay.
Well, if you guys want, we can also have another call between now and next Monday. I suggested on Discord to Tim that we might brainstorm it just between Sandidia himself and myself, and if we can look at it in more detail, maybe we come up with something until next Monday. And then next Monday is changing the centers, so we haven't lost any time really.
Yeah.
Okay.
If you guys are up for that.
Yeah, happy to.
Sandelia, you want to do this weekend? That's when you think you'll be in the lab?
Yeah. Sure, that works.
If that works for you guys and around your schedules, I think that is a good idea.
I think so. Yeah, but otherwise it takes too long and it takes way too much time from everyone. I think.
Yeah.
And I might be a bit more focused as well.
Okay.
Hey,
Yeah, then
can
something else.
we not use hot glue for the situation?
Maybe. Yeah.
How hot does the unit get, though? Is there any possibility it would melt?
It doesn't get anywhere near that hot. By the way, Sendelia, there's a hot gun in the lab I left behind on the cart somewhere and a bunch of sticks that go with it.
Okay.
Yeah, hot glue is good because it's removable. So, like, if you decide to replace it with epoxy or something later, it's very versatile that way, and it's cheap and accessible. There's not much engineering involved.
And there's also a tube of something it's something like an instant gasket or something like that. It's just a tube of gooey stuff that you can spread around and it turns into rubber.
Yeah, I wouldn't try to like engineer a really complicated solution for this unless like hot glue or whatever David is suggesting isn't sticking because it might not be worth your time. Just get something to work.
I would say definitely what Tim and I think it would still be good to have that call over the weekend, I think, to look at it. But I think for the purposes of Monday, just to get to good enough, let's use the instant gasket and hot glue, particularly if it's already in the lab.
Okay.
Does that sound good, Sendelia? What I do, whatever matches your comfort would be good.
Yeah.
So
that works.
Okay. Okay, so we don't have to order that. I guess the only thing you have to get then is the mesh, and then the three of you, and if you want me on the call, we can do it. I won't have much to help with, but can certainly make time over the weekend. But I guess what we'll plan for, Sendelia, and reach out to us if you have any needs before that. But we will aim to live put the servant in, and then fix the sensors, and then run the system. So the changes to the software have to happen before then. Tim says he can fix, but let us know if there's any major uncertainties or barriers that would prevent us from doing that between now and next Monday that we know of, Sendelia, that we have to track. Okay, cool. Well, we have just about 5 minutes more time. We can end early. Did anybody have any? Ling, did you have any questions since you've been off the last few weeks? I didn't know if you, just for in the interest of catch up.
No, not much. Besides the ones I already asked.
Okay, great. All right, cool. So does Jochen and Sendelia and Tim, I don't know if you all have each other's email, but I can connect you all right now by email so you can schedule that. But then
please do.
Yep. Otherwise, we'll be back here next Monday, hopefully with some things to put into the unit. And again, I know you say this every time, but Sendelia, thank you so much for playing this role. It's really opportune for us. So, okay, cool. We'll see you next Monday, but we'll talk in the meantime, and looking forward to it.
Thank you.
Enjoy your week, guys.
Great week. Bye.
Bye.